grasp the idea of concavity, we must first have the idea of a particular application of derivative. By the end of this video, you will have a good understanding of the concavity as it is primarily the topic of this video. Derivative tells us a lot about the function, but let's analyze how the slope of the tangent, which is the derivative at the point at which the tangent is drawn, tells us about whether the curve is sliding down or rising. As can be seen from the graph, when the curve of the function is sliding down, the slope of the tangent is always negative, and when the curve is rising, the slope of the tangent is always positive. As the function 2 times x is the derivative graph of the original squaring function, so as the derivative is negative for all x less than 0, so for this domain we know that the function x squared is sliding down without even drawing the curve. And as the derivative function is always positive for x greater than 0, so squaring function rises in this domain. Let us just sum up all what we have learned so far, that if the derivative is negative in an interval, this means that function is decreasing, and if the derivative is positive, the function is increasing. But there is more in the scene if we consider how the slope itself is increasing or decreasing in the given domain, which is essentially the second derivative of the given graph. Consider this function curve which is decreasing in the given domain, but there are 2 scenarios in which the slope of the tangent can behave in the given conditions. First, when the slope of the tangent is decreasing, the curve is said to be concave down, or when the slope of the tangent is increasing in the domain, the curve is said to be concave up. In the concave up case, the first derivative, which is the slope of the tangent, is negative, but the second derivative, which is essentially how the derivative itself is changing, is positive. Now considering the case in which the function is increasing, which means the first derivative is positive, there are again 2 scenarios. First, when the slope being positive is decreasing in the domain called concave down, and in the other case the first derivative while being positive increases in the domain, and the second derivative is positive, and the curve is said to be concave up. Now let us consider the function x squared, which you may already know to be the graph of the parabola, but let's verify its graph using the knowledge of the first and second derivative. As the first derivative of the squaring function is 2 times x, which is positive for x greater than 0 and negative for x less than 0, which means that the function x squared is increasing when x is greater than 0 and function is decreasing when x is less than 0. Now considering the second derivative, which is a positive constant in all of its domain, expresses the first derivative just keeps on increasing, which is another way to say that the slope of the tangent keeps on increasing in the first graph. So now we know that the first derivative is negative and the second derivative is positive in the second quadrant, which means a concave up with a decreasing function, and as the first derivative and the second derivative both are positive in the first quadrant, which means concave up with increasing function. So there we have a perfect graph of x squared.